Hello everyone. Okay, for this new chapter, I'm going to start off from bringing you from what you have learned in primary school to what you're going to learn in your secondary school. Now, what you are shown here is a very simple electrical circuit, which many of you are familiar with. And in primary school, you have learned that when a switch is closed, the electric current will flow. So for part of this chapter, we're going to answer these few questions. What exactly is an electric current? And what causes electric current to flow? And how much electric current actually flows? Okay, so first, what exactly is an electric current? Okay, the current that I've drawn here, this current, okay, this arrow shows the direction of conventional current, right? This is the more the current that you're familiar with, but we have a name for it. It's called the conventional current. It flows from the positive terminal, which is here, right? It flows from the positive terminal through the closed circuit to the negative terminal, right? It flows from the positive terminal through the closed circuit to the negative terminal. Okay, so this is what we commonly known as the conventional current. And the proper definition will be electric current is defined as the rate of flow of electric charge. Right, charge you've already covered in static electricity. I'm not going to dwell too much on it here. So from this definition alone, electric current is defined as the rate of flow of electric charge. How do we get the mathematical expression out of this? Rate. When we talk about rate, we know it has to divide by time. So when we talk about rate, we know it has to divide by time. And this is electric current. So we let I represent the electric current. Okay, so electric current is defined as the rate of flow of electric charge, flow of electric charge, and that's represented by Q, right? And hence we have current equals electric charge over time. Okay, so generally you just get this idea. When we talk about rate, it means divide by time. Now in short, we don't really like to write out the whole word, so I equals Q over T, and Q refers to flow of electric charge. The SI unit is coulombs, represented by capital C. And the time, SI unit is in seconds, represented as small letter s. And for electric current, so this is new to you, for electric current, the SI unit is ampere, represented by letter A. Okay, so we have one formula here, current equals charge over time. Right, so this is what electric current is. But what actually causes the electric current to flow? Yes, we know that it flows from positive terminal through the closed circuit to the negative terminal. So what exactly causes the current to flow? So what we need is energy. We need the energy to drive the electric charge around the complete circuit. And in your primary school, this term is commonly known as the voltage. However, in your upper secondary, it's better to use the term what we call electromotive force. This is electromotive force. So sometimes when you read other textbooks, it's written as EMF, electromotive force. So what exactly is electromotive force? It is defined as the work done needed to drive 1 coulomb of positive charge around a complete circuit. Okay. 1 coulomb of positive charge around a complete circuit. So this statement here actually implies, this actually implies that we use EMF for source of energy. Example, battery. Right, we use electromotive force when we want to know the voltage across a battery. So we use electromotive force. Right, so this statement, this phrase here, around a complete circuit, already implies that. Right. Okay, following that, work done. To drive 1 coulomb of positive charge around a complete circuit. Work done to drive 1 coulomb. Okay, so this will tell us that's work done divided by coulomb is actually refers to charge. Right? So that tells us electromotive force equals work done over charge. So in short, we just write it as V equals W over Q, where W refers to the work done, SI unit is joules. Again, you already covered that in chapters 5 or 6, I think. Q refers to flow electric charge, SI unit is coulombs. And this one is new to you, right? V refers to electromotive force, and SI unit is volts. Okay, so this is a second formula that's introduced to you. V equals W over Q. Right, so you have I equals Q over T, V equals W over Q. Two formula at this point. So EMF usually refers to here. Alright. So if the battery is 1.5 volts, we just say the EMF equals 1.5 volts. Right? You can also write V equals 1.5 volts. Okay, up to your preference, but it is basically up to your preference. Okay, so now for here, we really covered the energy needed to drive the charge around a complete circuit. So what happens when the charge arrives at the electrical component? So the current flows and arrive at this point here. What exactly happens?